Okay, let's assume that a function, let's assume that it goes through a point on the y-axis. Say 0, 1. What will the slope, if the height is 1, the slope has to be 1. Okay. So what would that look like? Well, then the next point, if I went over another distance, the value would be higher than 1. And if it equals its slope, so it's going to look like this on the right. On the left side, the slope is 1, it's going to go down a bit and flatten out, and the slope will get more and more flat. You may ask why I didn't have it go through the origin. If it goes through the origin, the height is 0, the slope is 0, it's going to keep staying on the x-axis and be the constant function 0, which is equal to its own derivative. Let's just take a look at 2 to the x. I'm going to go through 0, 1. Let's label this as 2 to the x. And then through 0.001. Calculator says trace that 1.0006934, whatever. What is that? If you look at the approximate tangent line by looking at the secant line, it's a little not quite steep enough. Okay. Why am I looking at 2 to the x? Because the graph in this first problem kind of looks like the rocket ship function. It looks like an exponential function. Let's try 3 to the x. Okay, the 1's cancel and you get 0.0010 whatever. It's going to be 1.099. I wonder what that number is. Is it related to 3 to the x? Okay, let's try e to the x. That slope is awfully close to 1, and it gets closer. As soon as you get really close to 0 to the y-axis. So yeah, it turns out e to the x is its own slope. It is its own derivative. First off, I need a preliminary thing. I'm going to fake. We're not doing a slope, not a slope. So let's see, a table of values. Let's do it this way. I'm going to do it horizontally, and I'm going to say, oh, I probably need more places for that. If I go close to 0 by going 0.01, yeah, 0167. Okay, and if I get close to 0 on the left-hand side, the height is approximately 1. Okay, so let's take a look at the limit definition of the derivative. F of x is e to the x, so we have e to the x plus h minus e to the x all over h. How on earth do you simplify that? Remember, adding in the exponent is really multiplication in the real world. So what we have is we have a common factor in the numerator of e to the x. And unlike what most people did on the last unit test, oh my goodness, if you factor out e to the x, let me just write this down. If you factor out e to the x, you have e to the h minus something. You can't lose a term when you factor things out. If you cancel everything out, you've got a 1 behind. Okay, now notice h is the variable. E to the x, let me write this in blue. E to the x isn't involved with h. So if I'm going to do this, I can actually pull the e to the x outside and look at just the limit of the rest of it. Oh, that is this is the previous problem. So this is so that's what I was saying, you use the number from part A. So this is e to the x times the number 1 as a limit is e to the x. So first off, the derivative of e to the x is e to the x. Let me write that in purple. It's its own derivative. Cool. So we'll just as a brief mention, because I have worries about people thinking that's an actual proof. Doing things by approximating on the calculator doesn't really necessarily prove anything. We'd have to do a lot more formality to actually prove it, but we're just verifying it. Okay. Derivative notation, the prime notation, or the d thing dx. Derivative of e to the x is e to the x. Derivative of 2x is 2. Second derivative means derivative of the derivative. Okay. Derivative of 2 is 0. 5 comes along for the ride. Oh, so here's another function that is its own derivative. But notice the polynomial gets creeped down. I just wanted to do several of them just to remind you of what the derivative of e to the x was. Derivative of 7 is 0. Don't forget to drag down the negative. There you go. Okay. From the previous notes, we had y equals x squared times x cubed, which is, as we know, x to the fifth. Y prime must be 5x to the fourth. But if we have f of x is x squared and g of x is x cubed, is the derivative of the product just the product of the derivatives? Well, let's just see. Derivative of x squared is 2x. Derivative of x cubed is 3x squared. The product rule will end up being more complicated. So be careful. We will learn the product rule in 3.3, but for now, we must distribute. Which means we can't even do x times e to the x yet. So I'm going to rewrite square root of t as t to the 1/2 so that I can combine the exponents. So this is my original function, and before I take the derivative, I still need to simplify it and write down negative exponents. 3 over t is 3t to the negative 1. And we add these two exponents. So, shall I call it f or y? I don't care. F prime is 0 plus negative 3t to the negative 2. We pop the exponent down. And then 1.5 t to the 0.5. There we go. A little note. Remember, the other notation for derivative is dy dt in this case. All right, so acceleration. Why am I writing in blue now? I don't know. Okay, back to red. Okay. Interesting. Oh, per second squared. Dude. Bad dude. Okay, so it's stronger than the Earth's gravity, at least at the surface of planet X. something from physics. Gravity gets weaker and weaker as you get closer to the center of a planet. Just for your information.